Welcome to Chapter 13, Classifying and Predicting New Records. In this chapter, we will explore classification and regression trees, their applications, and how they work. Let's get started! By the end of this chapter, you will be able to describe classification and regression trees, apply regression trees to classify new records, apply ensemble tree models to predict new records, and apply ensemble tree models to classify new records. Decision trees are a popular supervised data mining technique. They are easy to interpret and represent a set of if-then rules. There are three types of nodes. Root node, the top node of the tree where the first variable split is applied. Interior node, where more decision rules and splits are applied. Leaf terminal node, where classifications or predictions are given and no more splitting occurs. The splitting process is repeated until each subset contains only cases with similar values for the target variable. Pure subsets consist of leaf nodes that contain cases with the same value of the target variable. The process is recursive, and sometimes it may not be possible to reach pure subsets due to identical observations with different target variable values. The CART algorithm successively splits cases into increasingly homogeneous subsets based on predictor variable values. Decision trees produced by the CART algorithm are binary, with 2 branches for each decision node. They are built using partition datasets, training, validation, and test datasets. Let's take a look at an example. Sunnyvale Bank's retail banking manager, Hayden Seller, noticed a decline in the bank's HELOC business. Hayden believes the decline is due to not targeting the right customers. They compile data on 500 past customers and collect age, gender, and income from 20 new customers. The goal is to develop a classification tree to predict whether a customer will respond to a HELOC offer. Using the data collected, let's construct a classification tree since the target variable is the binary variable, yes or no response to a HELOC offer. To begin constructing a tree, first select the top of the tree known as the root node. The root node can be numerical or categorical. Continuing with the example, we establish the numerical variable of age as the root node. Customers under the age of 50 are situated at the bottom left branch, and customers aged 50 or greater are located under the bottom right branch of the root node. The income variable is an interior node. The split value for the same variable can be different if it originates from a different branch. We can see in this tree, the split value for customers under the age of 50 is 100,000, whereas the split value for customers at least 50 years of age is 50,000. The bottom nodes of the decision tree are called leaf or terminal nodes. This is where the classification or predicted outcomes are determined. In this example, the terminal nodes indicated whether a customer will respond to a HELOC offer. Often datasets may not be as simple for manually constructing a tree. For larger and more complex datasets, we can use JASP for building classification and regression trees, referred to as CART, throughout SAGE 13. The approach will first grow the tree using the training dataset, selecting optimal splits of all predictor variables until no further splits can be made. The decision tree at this point is called a full tree or maximal tree, which tends to overfit the data. The validation data is used to optimize the tree's complexity by pruning it to a simpler tree, resulting in a set of candidate trees with different levels of complexity. Pruning removes branches to improve the tree's ability to predict more accurately. The minimum error tree is the least complex tree with the smallest validation error. The best pruned tree is the least complex tree within 1 standard deviation of the minimum error tree and can be used as the final model. CART is versatile, easy to understand, and can handle both categorical and numeric target variables. It automatically selects the most discriminating predictor variable and can handle incomplete data and outliers. However, it requires a large training data set, has high computational cost, and small changes to the training data can result in drastically different trees. Thank you for your attention. This concludes our discussion on classification and regression trees.